Hey guys, so our first lesson is going to be in geometry. We're going to start with some of the easier stuff, just some definitions. We are going to do some examples together, and then um, you guys will go and do your notes, which you will have a copy of the teacher's notes as well as your virtual, basically notebook. And then after you go through and do those notes on Wednesday, I will post the test. All of the work will be done on Friday. So if you do not have time to do it on Monday or Tuesday, I understand. Make sure that you are signing in for attendance every day. If you are on a paid status right now, we want to keep you that way. So I know that some of the work may be too difficult for some of you since I have all three math classes right now, but just try your best, okay? The grades don't really mean anything. We just have to prove that we are showing you and teaching you and the whole nine yards. So we are going to start. We have three terms that you guys should know. A parallel line is two lines that have the same slope but different intercepts, meaning they cross the y-axis at two different spots, and they never intersect each other. Then you have perpendicular lines, which create a right angle or 90-degree angle where they intersect, which means they cross. We also have a straight angle, which we also know is just a straight line. And then a ray is the path. Oops, sorry guys. This is a new thing for me too. Oh, just like the smart board at home. The computer's not that smart either. Okay, so how do I make that disappear? I guess I don't. So a ray is a straight path originating at one point and extending endlessly or to infinity in the other direction. So if you are to draw an angle, you have two rays that intersect at that center point. So these two lines would go on forever, but they're intersecting at that center point or your vertex. Oh, and we also have angle, which is where the two rays share that vertex. You have an adjacent angle, which is when two angles that share one line. So if I had an angle in the middle and then I were to have my pencil come up straight, this middle line would be my adjacent angle. And then you have vertical angles, um, which are the angles that are opposite to each other when lines cross. So when you have two perpendicular lines, all of your vertical angles are 90 degrees because everywhere those two perpendicular lines cross, you have a 90-degree angle. Oh. So then we have some more vocabulary. Supplementary means you have two angles that add up to 180 degrees. So you can look at the picture and you will see that your 180 degrees is your straight line on the bottom, and then you have a ray that comes up through the center of that line or any point on that line, creating two separate angles. Then you have complementary angles, which are two angles that add up to 90 degrees. So you have your ray in the center, again, that's going to break apart those two, that one single angle into two separate angles. When you are looking at complementary angles, remember they are both not always 45 degrees, which would be half of that 90-degree angle. They can be 3 degrees and 87 degrees. It depends on where your angles lie, or your ray lies within your angle. And then you have transversal, which is a line that crosses two other lines at different places. So that will be important when we're looking at how to find other angles, kind of having an idea of what that means. We have angle addition, postulate, which is the sum of two adjacent angles is the measure of this the angle that is together. So when we talked about how you have two angles that equal 90 degrees, being complementary angles, that is the same thing. When you add those two angles together, it equals a number. So it's just saying that the angles of those two smaller angles added together will give you the larger angle. You have a segment addition postulate, which is If we're given 2 points on a line segment, A and C, and a third point B lies on the line segment, AC if and only if the distance between the points meet the requirements of the equation AB plus BC equals AC, meaning that if you have a point in the middle of those 2 points that the A plus A to the B and then the B to the C, when added together, will equal the A to the C, which makes sense. You also have exterior angle theorems. When you extend the side of a triangle, that creates an angle. And that angle is equal to the sum of its non-adjacent angle, meaning it is equal to which sum? What does non-adjacent mean? It means it is the one that is not next to it. So we know that if you look at the picture, angle 1 has an angle right next to it. You don't look at that angle when you're talking about exterior angle theorem. You're looking at the 2 other corner angles. Those 2 other corner angles are, when added together, are equal to that exterior angle. So here's the concept, right? Your magic number is for lines and angles is 360 degrees. We know that 360 degrees is in a circle. You imagine the diameter of a circle, it cuts the number of degrees in half, right? That makes sense. Everybody knows that. So what does that give you? Well, think about it. What is half of 360? Half of 360 is 180. If you have 180 degrees, that is the degrees of a line. So that angle is called also a straight angle. This is the simplest angle. So simple it barely meets the definition for an angle. Normally, we think of an angle as the intersection of 2 rays which originate at a single point, the vertex. So a straight angle doesn't really have a vertex because it is just a straight line. So here's some pictures so you can see. There's your 360-degree circle. When you cut through that, you have 180 degrees. So thanks to the ancient Babylonians, we use 360 degrees for the number of degrees for a circle. It's an arbitrary number, but a convenient one. 360 has many factors, so you can have pie slices of many possible sizes, all in integer degrees. So here's the first concept, adjacent angles. If you take a straight angle and make a third ray from that point, or a line from an arbitrary point on the line, what's going to happen? You have now made 2 adjacent angles. They have the same vertex and share a ray and a side. Their sum is 180 degrees. So I am going to pull this over to the side so you can see my little whiteboard. Maybe, if it'll do what I want it to do. So here's my whiteboard, right? And don't mind me looking down. I have the whiteboard app on my iPad, so I can draw directly on the iPad and you guys can see it. So I am going to draw a line. There's my straight line, right? Pretty nifty. So if I draw any line, so I'm just going to pick a random line and I'm going to draw that ray. Here's my ray, okay? We know that from here all the way over to there is 180 degrees. I'm going to make it up and say that this angle is 105 degrees. So what we want to know is, how big is this angle? Makes sense, right? So basically, this is our adjacent angle. our adjacent angle plus this, our angle, we'll say this is angle A, and this is angle B. Angle A plus angle B. So angle A plus angle B will always equal 180 degrees when our degrees are on a straight line. So think about it. We have 105 degrees plus x degrees equals 180. We know how to solve this. You're going to subtract 105 from both sides, which will give us 75. X equals 75 degrees. Don't forget your degree sign. So x equals 75 degrees, which means B, or angle B, also equals 75 degrees. Okay? I'll zoom out a little bit so you can see better. So back to our slides, right? I'm going to open this back up. I am going to go to my little present button, and we're going to keep going. So we just did this together. I showed you the example, and you can see how those two adjacent lines are also supplementary, meaning they equal 180. Then it says angles may be named with the letters, but sometimes numbers are used for distance. Angle CEB is the same as angle 5. That's fine. We've seen that before. That's not something that we're really learning, okay? So let's see why this isn't working. So if you look, line AB intersects line DC at E. That is the point. But angle 5, what are they talking about? They're talking about the area between, see if this will let me use a pointer. So angle 5 is this angle right here. That is angle 5, okay? So angle 5 is not the angle measure. If it was the angle measure, it would say 5 with the degree sign. It would say 5 degrees. Concept 2, supplementary angles. Two angles can be supplementary without being adjacent, but adjacent angles along a line are supplementary. So just because when a line is equal to, or two angles are equal to 180 degrees because they're on a line is not the only time they can be supplementary. Any two angles that when added together equal 180 degrees are supplementary. So it could be two angles, for example. So here is our supplementary line with them being adjacent to each other. We know that angle A plus 45 will equal 180 degrees, which means angle A is 135 degrees. But if you know the measure of one angle, you can always find the second angle. We just did that, right? But so same thing here. This is just an example, right? So you have 107 degrees plus angle A is going to equal 180 degrees because you still see there that is a supplementary. It is on that straight line. So angle A is going to equal 73 degrees. Do the math. There you go. Now you have complementary angles. Those are the angles that equal 90 degrees. So a right angle has a measure of 90 degrees always. If a line segment cuts that angle, then the two pieces still sum to 90 degrees. The two angles are complementary. Complementary angle sums equal 90 degrees. So remember, supplementary is 180 degrees, complementary is 90 degrees. So they show you an example. Here's a 90-degree angle with a ray coming out through the vertex. You have two angles, one's 50 degrees and one's 40 degrees. Add your 50 and your 40 together and you will get 90 degrees. The angle has not changed. It has just been split into two angles. In this case, they are also adjacent angles, so they share a ray. They share that line that comes out through the center. So here's a second example. You have the measure of angle BAF equals 90 degrees. Find the measure for angle A. So if you know that the angle of, see, this question is kind of a silly one because when you think about it, it's telling you what the angle A is, right? You don't have to do any math here. It's telling you that the measure of BAF equals 90 degrees. Because A is the center and F and B are the two furthest rays away, right? So here's your 90-degree angle. You have B over here and A over here, or an F over here. This vertex is 90 degrees. It's telling you the answer. But another way, if you didn't realize that as you read the question, is to do the math. So you know that the one angle is 57 degrees, right? Your total is 90. You're looking for little a. 90 minus 57 gives you what? If you said 33, you are correct. So here we're going to talk about the angle addition postulate. What if the adjacent angles don't make a straight angle or a right angle? Well, again, we're going to do one example on here, and then I'm going to go and I'll go back to my whiteboard and I will show you some actual notes. So let's see. What am I correct? So what if the adjacent angles don't equal that straight angle or right angle? The sum of the two adjacent angles is the measure of BAD, as though AC were erased. The total is 31 degrees plus 27 degrees, which equals 58 degrees. Two parts make a whole. That is just what angle addition postulate means. So you can also work backwards. So you have an angle, BAC, or BAD, which is split by ray C. And you know that one side of that ray or angle, DAC, is equal to 50 degrees, and X is your BAC angle. If you know that BAD is 85 degrees, then X has to equal 85 minus 50 equals 35. So if you had a question like this on your test or for anything that you're doing, you would have to know what BAD as a whole is, right? And it makes sense. If you add two numbers together, you get a total. If you take that total and you subtract one of the numbers you added originally, you're going to get that other number. That's the addition property. We've known that, and we do that with plenty of other aspects in math, right? And in real life, for that matter. So in the coordinate plane, angle BGZ has a measure of 5x. And ZGW has a measure of 6x. If BGW has a measure of 77 degrees, what are the two angles? So go back to my whiteboard, pull this over here so you can still kind of see it. Still learning, guys, so please, please bear with me. Go to a clear spot on my whiteboard. Okay, ready? So again, I'm going to draw my angle. My angle is obviously not going to be quite as pretty as the other angle, but I will do my best. That's an eraser. So here's my one line. Here's my other line. And then my third line. I apparently need to zoom out for you. So we have angle we have angle that we have G, we have Z, and we have W. The information tells us that BGZ has a measure of 5x. So B is here, G, Z. That is talking about this direct angle right here. Okay, this is equal to 5x degrees. Then we have this angle, which is equal to, very strange that my 5x did not show up. 5x. Interesting, friends. Okay, there's my 5x. I zoom back out a little bit. And then here's my degree sign. And then I have 6x for my secondary degrees. So, step one, what is my total angle equal? So I have BGW equals 77 degrees. Well, using our algebra skills, we know that if this entire thing equals 77 degrees, then this plus this is going to equal 77 degrees. So 5x plus 6x equals 77 degrees. Now we're just solving for x. 5x plus 6x is 11x equals 77 degrees. What do we do next? Our next step would be to divide out our 11. Divide by 11. 77, because our 11's cross out, will leave us with x equals 77 divided by 11. 77 divided by 11 is 7, so x equals 7 degrees. Does that give us our answer? No, right? Because we don't have just an angle x. We're trying to figure out what angle BGZ equals and what ZGW equals. So we're going to scoot our little thing over just a little bit. So we have BGZ equals 5x. Our x equals 7, so you're going to do 5 times 7 degrees, which means BGZ, angle BGZ is going to equal what? 35. Very good. Then we have angle ZGW, which equals 6x. 6 times 7 degrees equals what? Well, little reminder here. 6 times 6 is 36. 36 plus 6, which would get you 6 times 7, would be what? So we have 42 degrees. So we just did all the math, right? But do we really have to solve both parts of the equation? No. So once you solved, writing a different color pen for you. Once you solved for 1, you could have taken that number, right? You could have taken that 35 and you could have said, well, we know that the total number of degrees was 77. We could have subtracted that 35 and we would have still gotten 42 degrees. That number and that number will be the same. So it's a good way to check your work. It's a good way to make your work a little bit faster if you're not that great at your multiples and things like that, but you are really good at addition and subtraction. It's a fantastic way to solve some of those problems. So now that we've done that, we're going to go back, make my screen big again. I'm going to go to my presentation. Oops, that's not what I wanted. So we don't need to go through all of that already because I did it. So when you have angle addition, you're doing the same thing. DAB equals 143. They give you 1. You know that both of those angles will equal the total angle. So together, if the two angles are 143 degrees, you are going to subtract the 39 to get 104 degrees. So, segment addition postulate. Just as two adjacent angles combined to make a larger angle, two segments can combine to make a longer segment. Makes sense, right? So if A, B, and C are collinear here, collinear means they're all on the same line, you can see that from A to B, you have 2. From B to C, you have 3. So what would A to C be? How would we figure that out? So you're going to add your 2 line segments together. 2 plus 3 is 5. So that means line AC is 5. Makes sense. You could be given a distance and x for part. So the same way we figured out what part of the angle was given part of your supplementary angle, we can do the same thing with a line segment. So you can be given ABC, line ABC. If AB is 6 and CB is 2, what is AC? Do the subtraction. 6 minus 2 is 4. So in this case, if we have AB equals 20 and C is on AB, what are AC and AB? So this is where things can be confusing, but it's the same thing. You're just adding. So you are going to add 5x minus 2 plus 2x minus 1. When we are adding our equations like that, and I'm going to write it out on my whiteboard, and I will bring it up for you guys in 1 second. 5x minus 2 plus 2x, whoa, 2x plus 1 is equal to a total of 20. So I'm going to go back so you guys can see. Oh, whoopsie. So here's your numbers, right? First things first, combine your like terms. So my like terms in this are 5x and 2x, and then 2 and 1. Step 1, right? So I'm going to combine those like terms to eliminate a few steps. 5x, always look at the one before the second number, plus 2x is 7x. Negative 2 plus 1 is negative 1. It's a little less scary now, right? Because now we have 7x minus 1 equals 20. What's the next thing we do? We always get our exponent, or not exponent, whoa, our variable alone. So this is our variable. We need to get rid of this 1. You are going to add 1 to both sides of your equal sign. You will get 21, negative 1, plus 1. They cancel out. You end up with 7x equals 21. Your next step, divide, right? Because if we have multiplication, the opposite of multiplication is to divide. So divide each side by 7. X equals what? Take a minute, think about it. How many times does the number 7 go into 21? X equals 3. So, does that answer our question? Do you remember? No, it doesn't really answer our question, right? All that told us was what x equaled. So now we need to figure out what these line segments mean. So let me grab out my handy dandy ruler. I can draw myself a straight line to show you guys. And move my whiteboard a little bit more. So here we have point A. Here we have apparently point C, because they like to put point C in the middle. Point C. And then here we have point B. We know that point A to point C, not O, was 5x minus 2. So you have 5x minus 2. And for your second point, you have 2x plus 1. Obviously, guys, my line is not to scale. Please don't judge. But now you're going to take your x equals 3, and you're going to input it into each equation. So line AC, I hate that it keeps turning my C's into O's. Struggle is real, guys. So line AC, the line goes on top because we were talking about a line segment. We're only talking about from point A to point C, equals 5x minus 2. 5 times 7 minus 2. 5 times 7 is what? 35. 35 minus 2 is 30. What? What am I doing? See, this is why I can't teach without you guys, because you would have caught my 7 mistake and been like, huh, Miss Herman, that ain't right. So, try this again. 5 times 3 minus 2. 5 times 3 is 15. Subtract your 2, you get 3. AC, again, it changed my C to O. I don't know why it keeps doing that. AC equals 13. And then CB equals 2x plus 1. You're using that same x equals 3. So you have 2 times 3 plus 1. 2 times 3 is 6. 6 plus 1 equals 7. See? CB equals 7. Getting there, guys. A little bit longer. I'm sorry. Bear with me. Trying to make this go fast. And you know that at any point, if you need to go back and check, you can always rewatch these parts. You don't have to watch the whole thing. I don't even mind if you fast forward through the parts you understand. So right on to the next part. So we just did all of this. Here's another example for you, or more example of what we just did together. Now we have vertical angles. Back to the angles. Take two lines that intersect. Each side of each line, there is a straight angle. That is the angles on opposite sides of the x, formed by the intersection of the two lines. which are congruent. These angles are called vertical angles. So if you were to look at angle CEB and angle AED, they would be the same. If you looked at angle BED and CEA, they would be the same if you measured them out. So if we were to find x, given these two angles, you would have to set the two equations equal to each other. 8x minus 39 equals 5x. And then you will solve for x. So the two vertical angles are congruent, which means they are equal. 5x equals 8x minus 39. There's my equation. I'm going to get my variables by themselves. So if you subtract your 5x from your 8x, you get 3x minus 39. And then you're going to simplify. So you're going to divide each side. 3x or 3 divided 39 divided by 3 will get your x by itself. You get x is 13. And then you're going to evaluate, which means you are just going to put in your x into your equations. If solving equations is something you need help with, please let me know and I will assign you assignments specifically for that. Do not tell me because I can't see you, and even though I am checking your work, that doesn't necessarily always show you know what to do. You guys know that when you struggle in class, I can usually see it on your face. I don't have that opportunity anymore. So together, we really have to work together and work hard on figuring out ways around those struggles since I am not there. So angles around a point. Remember that our first example referred to a circle. It measures 360 degrees. Then any set of angles that make a circle sum or equal to 360 degrees. That makes sense, right? So you have 4 angles, but it makes a circle because it goes all directions of the point. So all of those numbers, when added together, will equal 360 degrees. So you have 153 and 117, which equals 270. Then you have 34 and 56, which will equal, I think the math, 90. So when you add those numbers together, you get 360 degrees. So if you have angle x that you were solving for, you are going to add 127 plus 100 plus 27. So you end up with 254. Okay? You can use a calculator for that, I don't mind. 254, an x, and an angle with no number. We know that angles that are opposite of each other are congruent. So that means angle x and the blank angle are the same angle. They are the same length. So for your own benefit, you can draw an x in there. You can write that x down so you remember. But if you're able to look at it and say, okay, I know what this is, you know that it's really all those numbers plus 2x. So you're going to solve. Your vertical angles are congruent. So 127 plus 27 plus 100 plus x equals 360. 2x equals 106. You may be thinking in your head, how did they get to 106? Oh my God, I'm so confused. Don't be. All they did was take their 127 plus their 27 to get 154. Then they added their other 100. So now you have 254 plus 2x equals 360. They subtracted their 254 from each side to leave them with a 106 and your 2x. So 106 divided by 2 is 53. And yes, I did just do that math in my head. So now let's combine it. Well, do all our points make a circle? How are we going to figure it out? Well, if you know that angle BAD makes a right angle, you know that x is part of 90 degrees. So you need to look at everything else though, because that's not enough information. EAC is clearly a straight line. 107 minus your 180 gives you 73. That means angle BAC is 73 degrees. If you know that angle BAC is 73 degrees, then you can figure out what angle X equals by subtracting 73 from 90 to get 17. The two adjacent angles make a right angle, which means they are 90 degrees. Here's another case in which you combine facts about angles and lines in the coordinate plane to make conclusions. So we know the exterior angle theorem means that the angle outside the triangle equals its two opposite angles. So suppose the line AB is extended to D. You know that line ABD is a straight line. It's telling you it's extending that line. So you know it's 180 degrees. Suppose your angles are as shown. But the angle ABC is in the interior of the triangle. Therefore, the angle CBD exterior to the triangle is the sum of the other two interior angles. That is the exterior angle theorem. So all that is saying, because it sounds a little confusing, is that if you look at angles CBD, where it says 104, and then you look at angle A and angle C, and you add them together, 53 plus 51 equals 104. You can see that that 104 of those two added angles equals the singular angle on CBD of 104 degrees. Okay, so for today, this is where we're going to stop. I'll make a secondary video going on over parallel lines and perpendicular lines because there's still about, I would say, 10 or so, 6 slides. And I don't want to overwhelm you, which I probably already have. Like I said, I'm just getting used to this. Please let me know what works for you and what doesn't work for you. If you need me to do more, maybe keep it split screen the whole time and do more examples as I go. I'm trying to figure it out. But you guys also will have the notes, which has all the examples and how they did it posted with this video. Have a great day, night, guys. I'll talk to you tomorrow.